Good morning, Vietnam. All right, let's do this. We've got exponentials with like bases. We just log base 2 both sides. Easy. And solve. 4x equals 8, x equals 2. This is a log both sides. Well, actually, or we could write 1 as 3 to the 0. And then we can just say x plus 7 equals 0, and therefore x equals -7. Alternatively, you do log base 3 on both sides, and you get x plus 7 equals log 3 of 1. But log base anything of 1 is equal to 0, so that just kicks you back over to here. I guess I should do the ones that are the same style, so we'll go to number 2. This was what I referred to as a type 1 exponential, so this is 4 squared to the 3x. Which is 4 to the 6x is equal to the other stuff. So x plus 13 is equal to 6x. So x is equal to 13 over 5, I think, if I didn't screw that up. All right, 4. We cannot make one the base of the other, but we can make them a common base because they're both powers of 5. So 5 squared to the 2x equals 5 cubed to the x minus 3. So 5 squared to the 2x, that's 4x. It's going to be equal to 5 cubed to the x minus 3x minus 9. I did 2 steps there because I didn't do the log base 5 as a separate step, but we'll subtract 3x, we get x equals -9. All right, now some log questions. We will 4 to the both sides, we get x minus 1 equals 4 to the 4th, which is 256. So when we add 1, we get 257. 9 log stuff. Well, first of all, let's get rid of the 2, get rid of the 9. So log -3x is equal to, we subtract 2, it's 18, divided by 9, it's 2. So now we will do 10 to the on both sides. -3x is equal to 10 squared, which is 100. And we'll divide by -3. X is equal to 100 over -3, or just -100 thirds, or -33.3 repeating. Interestingly enough, the number we're using for x is a negative number, and that's okay, even though we're going into a logarithm, because the result becomes positive at time when we do it times -3. All right, 4 to the both sides, very straightforward question. So x equals 1. We're going to subtract 2 to both sides. So the log is equal to 2. And then we'll do 3 to the on both sides. We'll get 2x plus 2 is equal to 3 to the second, which, hey, we're back to 9 again. Subtract 2 is 7. And then divide by 2, x equals 7 halves. Subtract 5, that's 14. Divide by 7, that's 2. So log base 2 of stuff is equal to 2. Now let's do 2 to the on both sides, because log, so 2x plus 5 is equal to 4, 2 squared. And so subtract 5, that's -1, x equals -1 half. And yes, we can put that there, it's okay, doesn't break anything, so we're good. Number 10, -3x plus 4 is equal to 6x plus 4, because we did 5 to the on both sides. 9x equals 0. Oh, x equals 0. I should have been able to see that, right? You just cross them out and they match. Okay, so there's part 1. And then we scroll down for the next 4. You simplify using properties of logs. Be sure to simplify all final answers. Very angry text there. Oh my God, simplify all final answers. 1, 1, 1, 1, 1. Okay, so first of all, let's bring this inside so we have just logs and nothing weird going on. You know what, I'm going to use the text tool. This looks sloppy as heck. Text. Log 5 of 2xy plus log 5 of x to the third. And then, because we've got an addition outside, that means we've got a multiplication inside. So we've got 2xy times x to the third. And then because the instructions shouted at us very angrily, we will simplify that to 2x to the fourth times y. All right, log base 2 of 3yz. What do they want us to do with that? That's about as simple as it gets. I don't know what we're supposed to do unless the goal is to expand it, but that's not simplifying. That's going in the opposite direction. We could write that this is log 2 of 3 plus log 2 of y plus log 2 of z, but that's not simpler. That's more complicated. So I don't know what the goal is with this question. And the same is basically true for number 14 as well. Like that's log 5 of 3 plus log 5 of x to the 1/2 plus log 5 of y. And it's worth noting that we can rewrite that middle term as 1/2 times the log of x. But again, that's expanding, not simplifying. So I don't know. But if we go to 12, we can do some legit simplifying. So log 6 of x to the 1/2 minus log 6 of xy to the 6th. So log 6 of x to the 1/2. We're subtracting, so it's x to the 1/2 divided by x to the 6th. I can type, I swear, y to the 6th. So log base 6 of, let's see, that is x to the negative 11 halves times y to the negative 6th. Or you could just write it on the bottom of a fraction instead. So that's gross. Okay, let's hit 15 and 16 since we can see them. So 15, we've got a coefficient we should take care of first of all. So let's bring the coefficient inside. And then we will use the sum property to say this is x to the 5th times x minus 1, which arguably you could distribute. I don't know that that's better, but you can do it. So you'll have to gauge your teacher and whether or not they want it the way that line 2 is written or the way line 3 is written. You could argue one is simpler than the other, but which is the simpler one is up for debate. All right, log of xy whole thing to the third plus log of x squared minus log of y to the 5th. All right, so it is log of x to the third times y to the third, and then we've got the plus log of x squared, so it is times x squared, and then minus log y to the 5th is like saying in inside divide by y to the 5th. And now we need to simplify. We've got x to the third, x to the second, so that's x to the 5th. And then we got y cubed over y to the 5th, so it's like divided by y squared or times y to the negative second if you prefer. So that's just as much as I'm going to give you for this. Again, 13 and 14 strike me as weird questions. I don't know what's going on with 13 and 14 because there's nothing to do. And then we get to the fun stuff. All right, solve the following equations for x. So first of all, let us make a single logarithm on each side. And then we will 10 to the both sides. I'm distributing while I do that. Shift this over so it's lined up a little better. All right, so negative 2 equals 4x. So seemingly negative 1/2 equals x. Now, is that a legit answer we can use? And when I look at plugging that in either here or here, I'm going to be plugging in negative numbers. So we're going to say that it's extraneous. So therefore, no solution. Let me make sure I did that correctly. Did I screw anything up? Looks okay. Yeah, I think we're good. Okay. So 18. log y equals log log 4 log y minus 4. All right, well, we'll bring those together because outside add is inside multiply. Log 4y minus 16. This is very similar to a question I did last night. And then we will do 10 to the on both sides equals 4y minus 16. Negative 3y equals negative 16. Y is equal to 16 over 3. And can I plug in a 16 over 3? Here is no problem. If I subtract 4, is it still positive? 4 is 12 thirds, so 16 thirds minus 12 thirds. Yes, this is still positive. We're good. So 16 thirds is a legit answer. And then 19 and 20, it says solve for x, but we've got other variables. Or at least for 19 we do. 20 is just complicated. So we're going to have to get x equals, but it's not going to be a number. We'll just have to keep that in the back of our head. All right, so log 5 of, we are subtracting, which means dividing, x squared yz divided by x squared y is equal to 7. Now we're going to do 5 to the on both sides. Or hold on. If we simplify this, can we simplify this? We can simplify inside first of all. X squared cancels with x squared, y cancels with y. I believe we're just left with z. Oh, we can't solve that for x. We can solve it for z, but we can't solve it for x. I'm going to assume that we're supposed to solve it for z, which means that it is now 5 to the both sides, which is 5 to the 7th. And you can plug in a calculator if you really want to know what that is. But we're going to call this one z equals instead of x equals. All right, one more to go. We're going to do our best to simplify these 4 logarithms here. Log 2 of 2x plus log 2 of 4 to the third is equal to log 2 of 2 plus log 2 of x plus 2. All right, we've brought the numbers inside. Now, log 2 of 2x times 4 to the third is 64 is equal to log 2 of 2 times x plus 2. So that is log 2 of 128x is equal to log 2 of 2x plus 4. We will do 2 to the on both sides. 128x is equal to 2x plus 4. So 126x is equal to 4. So therefore x equals 4 over 126, or in other words, 2 over 53. Really? This looks like the kind of problem that should have a nice, neat answer. I was not expecting it to be 2 over 53. Could I have screwed something up? 2x, 4 to the third is 64. Yeah, okay. Seems to check out. Maybe we want to figure out what this is by plugging in the calculator, but this is my reaction to this problem. So there we have it. There is all 20 problems. Hope that was helpful.